All right, let's talk about something called market basket analysis. Today, we're going to pull back the curtain on how this really powerful data technique, which is at the heart of a lot of software, finds these super surprising connections in the stuff people buy. Businesses use these secrets every single day, so let's dive in.
Okay, so we're going to start somewhere we've all been, the supermarket. It seems pretty straightforward, right? But the way a grocery store is laid out, well, that's a really complex puzzle, and solving it is big, big business.
Have you ever really thought about it? You go in for just one thing, like milk, but you walk out with bread, eggs, and maybe some fancy cheese you weren't planning on buying. Is that just a coincidence, or is it all by design? How in the world do stores figure out how to arrange everything to nudge you into buying more?
And for the retailers, this is a huge deal. If they don't get what customers buy together, they're basically flying blind. That can mean messy store layouts, promotions that just don't work, and at the end of the day, lost sales. It's a real problem that needs a real data-driven solution.
So how do you solve a puzzle like this? Well, software engineers and data scientists, they don't just guess. They use a very specific and very powerful technique to find the hidden story inside your shopping cart.
And that technique is called market basket analysis, or MBA for short. Really, all it is a method for digging through mountains of transaction data. I mean, think of every single receipt a store has ever printed to find items that people tend to buy at the same time. It's all about discovering those hidden connections.
So how does the software actually find these connections? It works by creating these really simple but incredibly powerful if-then rules. These are called association rules, and they're exactly what they sound like. They follow this simple if-then logic. If someone buys this thing, then they're also likely to buy that thing. The whole point of the analysis is to hunt for these rules in the data and then figure out, okay, which ones actually matter.
Now, to know if a rule is meaningful, we need a couple of key measurements. The first one is called support. Honestly, just think of support as a popularity contest. It tells you how often a combination of items, like our bread and butter example, shows up across all the shopping trips. If you've got high support, it means this pairing isn't just a random fluke. It happens a lot.
The second measurement is confidence, and confidence is all about the rule's reliability. So if a customer buys the if item, the bread, what are the chances they also grab the then item, the butter? A high confidence score tells us that our if-then rule is a pretty solid prediction of how people will behave.
Okay, so let's switch over to the software side of things and see how this all gets put together. To find all these rules, you need a smart, efficient engine. In this project, and in a ton of real-world software, that engine is a classic algorithm called Apriori.
The Apriori algorithm is actually really clever. It works step by step. First, it just finds all the individual items that are popular. Then, it joins those popular items together to make pairs. And here's the smart part. It then prunes or gets rid of any pairs that aren't popular enough. It just keeps repeating this join and prune cycle, making bigger and bigger groups until there are no more popular groups left to find. It's a super efficient way to find that needle in a haystack of data.
So that's the theory, but let's see how this gets turned into a real working piece of software. This isn't just an idea on a whiteboard. This project actually built a tool that generates real insights.
So everything kicks off with the raw data, and it looks pretty much exactly like you'd expect, just a long list of shopping trips. Each line is what one person bought. But here's the catch. A computer can't really work with words like fruit and yogurt directly.
And this right here shows the very first critical step in the process. It's called data preparation. The software takes every unique item and just maps it to a number. So fruit might become 1, bread becomes 2, and so on. Now the algorithm has clean numerical data that it can actually process fast.
So the next step actually puts the user in the driver's seat. Through a simple interface like this, a store manager can set the minimum levels for support and confidence. They're basically telling the algorithm, hey, don't show me any patterns unless they happen at least this often and are at least this reliable. This makes sure the results are actually useful for their business. And after running the algorithm, boom! This is the payoff. The software gives you a nice, clean list of those association rules. And check this one out. If yogurt is purchased, then item fruit is also purchased. See? This isn't just raw data anymore. It's a clear, actionable insight. The store can now say, hey, let's put the fruit next to the yogurt and hopefully boost sales of both. From a messy shopping list to a smart business decision.
Now, we've been talking a lot about supermarkets, but the power of this kind of analysis goes way, way beyond the grocery aisle.
I mean, think about it. That customers who bought this also bought feature on Amazon, that's market basket analysis. Banks use it to spot weird combinations of purchases that might be credit card fraud. It's used in telemarketing, in manufacturing, pretty much any area where finding the hidden connections between events gives you an edge. That's why this matters so much. It's a fundamental tool for making sense of data.
And that brings us to our final thought. This whole technique is about making the invisible connections visible, the ones that drive so much of our behavior. It really makes you wonder, in all the data we're creating every single day, in any field you can imagine, what other powerful, game-changing patterns are just sitting there waiting to be found?